Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith, and today we're venturing on a new job. A couple days ago, this call came about, and I was asked if I'd be interested in taking on this job and helping them out. It is one of my viewers out there that notified me, and because of the videos, my plasma table, and a couple other things there, they were inquiring on whether this would be a good job for me or not. And I said, hey, text me some pictures and stuff, and they did text me some photographs of this. This is over, this company is doing a maintenance on a plant, and this is an exhaust fan. And so they text me some photos of it, and I'm looking at it, and I'm going, you know what, that ideally is a project that I can take on and be there for them, help them get out of the spot they're at. The company that this fan goes into is an exhaust fan, and then there's flame induction and everything else to burn off fumes or a vapor or some reason that they need to induce flames as well, and this helps push the ventilation out of the building. And this spins at I think they said 3,800 RPMs. This will be balanced after I'm done. They're going to send it out and have it balanced. So I know that question will come about. And this does have weights on it. You'll see that in some of the pictures. And it is important that it spin without vibrating all over the place. This failed because of lack of maintenance, and it has two pillow block bearings, and one of those bearings failed, and the shaft let go on that side, and this fetched up into the cage, and then we had separation. They kept that part. They didn't bother. I didn't really need that part here. They just dropped this off this afternoon from Connecticut. The flat plate that I need to burn out, both the 1/4 inch for the paddle and the 1/2 inch for the double web. It is a double web. There's a slug in the middle. The slug in the middle actually receives a Browning taper lock bushing. Taper lock bushing made by Browning is 3/4 inch per foot taper, which plays in nice with, you know, my capabilities of doing prop work and that. Excuse me. I'll be able to set it up, and I'll be able to bore that with no problem. Now, I can't swing this in the lathe, so we're going to be doing things in order and doing setups so that I can do the machine work on the hub, and then we'll be welding and jigging this thing together, and then it'll be out the door. So I've got to make sure that all the machine work that can be done will be done before the welding going on, including the keyway. Now, the keyway is 3/4 inch on the width. I only have up to 5/8 broaches in my stock. The jumping jack on the K&T, which I could do a keyway in there, is a little short on the whole stroke. So after I get done cutting out these star shapes, and before I get onto the 1/4 inch, we're going to be cutting out a few pieces of plate that I'm going to go ahead and make a bolt-on adapter that will hold this slug and or any round hubbed item like propellers or things like that into my little Milwaukee shaper. My 1908 shaper is going to be making some money for me here on this little project here. And it's probably been a long time since that thing has turned a dime. It's almost 25 years since I restored it, and it's been bolted down. And I know that some of you guys have been really wanting to see it, so hey, we might add some of that in on this video. All my video on this project has to do with whether I can do it without interrupting the speed of getting her done. All right, so I think that's about, well, no, I'll tell you, before this actually was on this way this morning, I was already playing on my Plasma Cam software and playing with what I saw in the pictures with shapes and trying to come to plan with what this shape, offset, and all of that was going. And what I come up with, one was 2 diameters on the center hub, so it's larger in between the 2 webs. So there's going to be a flange, so we'll be able to machine that. We'll do a finished machining on the center of the star shape, the 6-sided star, before we weld those on there. So they'll bolt on. They'll be precision located round or peripheral, and then they'll be sandwiched so that they're uniform as far as parallel to each other. All right, so that'll be an automatic right there on that alignment. I was planning out and taking my long scale and just a couple, and there's one pretty good blade. The rest of them are tweaked a little bit, so I was able to take and find out that the mounting surface that the blade is 1/4 inch off of center line. And then this back angle, it's not a true star, and the stars aren't equal to, or the point angle is not equal to center line because it is off center. So I had to find relationship between this angle and where it came to the hub, and then I was able to pick that up, and then I verified thickness and everything else at a certain point. So I'm real happy on reclaiming this exact shape. The radius that comes in, that's very important that these radiuses come in here and feed. I can see that, you know, with it taking impacts and everything else, it did tend to break loose here, and I'm looking at what kind of penetration they had and the register and everything else right here. These paddles or these sections by this old timer that made this a long time ago. This came out of another building and went into the building it was at, and the original maker is expired way before this thing was worn out. So he did do a good job. Each one of these is a different section, so there was actually 6 pieces put on each side of the hub, parallel on each side, and each one of those is fit up because you can see there's a weld seam, weld seam, weld seam there. And I'm going to be cutting these out, and there's going to be a uniform one piece deal on each side. So there's going to be a little bit different modifications, but this is because I have this plasma cam here now, and the original maker probably did these by hand. Okay, I don't think the center webs are 1/2 inch, the paddles are 1/4 inch, and everything looks like single bead. There's stagger welds, 3 welds on each side, inside and outside of the web. Anything that was done inside the web was done outside the web, and including the weld inside and the weld outside there. Anything else, we'll be catching that as we go along. All right. Let me get set up here, and I think we're going to cut out our first star section here. Okay, I think we're all set. I'm going to check this out pretty close here, and be ready to stop it if need be. Looks like a really nice cut. Okay, now it's going to go all the way up the top. Okay, now the reason why I started at that section of the plate is because I want the cutout to hang on to the big part of the plate the longest. So it'll be coming around here. It'll come close to this edge here, that edge, and then come back over there. That will minimize the warpage or the disc shape as the rest of this plate gets warm. Okay, now I'm stopping it there just because we have a little bit of debris right there on it, and it was actually surging a little bit, and it wasn't real smooth. The height adjustment is controlled by the current, and if it has a little bit of piece of material there blobbed up from the pierce, it will missense that amperage. This is I'm running about 55 amps, and this is 20 inches a minute. The reason why I'm going this slow is I want that crisp edge on this part. I'm actually watching real close because there's so many, the points are so narrow out here, and I'm watching them move a little bit with the heat. But they're coming back and they're normalizing right in between. This one's still a little bit hard. That one there, as it grows on that side, but as it goes away and comes out there, they normalize and come back and they ride in the center. Just like when we go to weld this thing up, we're going to be staggering all over the place here. That's a pretty clean cut. I got to take a shot of that because it just really is clean. All right, I'm gonna pop this out of here. I'm gonna lay this down, and we're gonna lay that on top of it here, and we're gonna double check and see how our shape looks. A little tiny bit of dross on the back, not bad. Yeah, we'll knock that off in a little bit. All right, let's put it right on here. Let's see what we got. Well, we got a little bit of a bend on that ear there, so it's keeping us from going in here all the way. And two weights are hitting right there. Let's flip it right on over. pretty cool. This blade here is bent back, so it's actually forcing it all to go that way there, but it's exactly equal all the way around, and I can see that if it just rotated right in there, it would be hitting exactly where it's supposed to be. All right, I like that. Okay, I'm gonna knock this off of here, and I think I'm gonna start laying out, because this wasn't a full sheet, so I wasn't able to get both of these shapes out of here. But I can get two out of the bigger sheet that they gave me. That's why I wanted to start here, in case I made a fub, and but I didn't. It's looking good. All right, we just cut off our slug here. We're going to be using for the center hub, and we're getting ready to set this up, and we're going to be drilling and roughing this shape out. But to get it started here, we need to dial it in, and what I like to do is use the lines in the chuck. This line here is real close to this 7.5 inch diameter here, so I just roll it around till I blend that line all the way around, and I just double check, not that I have them tight, but that there's no loose ones. Okay, I take my indicator here and get it set up, reading on the outside surface, and I go ahead and I just kind of come in close to the jaws here. All right, I roughly put that in there about 45 thousandths. And what I do is I go ahead and I usually just loosen a little bit on the lower side, crank it in. If I see it climbing a little bit on the next one, I move it. Kind of always keep your mind that on your other two jaws that you're not moving, you got to move those in accordingly, and it's a shortcut to go ahead and make a move on it if you can recognize that move at that time. Now it has like a dip from there to there, and then climbs. Okay, we're going to be moving and chucking this thing around, and we're going to be roughing it out. So getting this thing within about 3-4 thousandths on this rough OD right here, that we know there's a little bit of out around this, just by the way the indicator is moving on one location. But what you do, if this was rough casting on the outside, you could 4-point it and just go, you know, you can create your 0, and then go to the other side there, and you can see that it's +2. And you go ahead and you bring it down to 1. And then there's 1. There's 2. There's 2.5. There's 1.5. There's 1. Okay. All right, let's put it in some kind of gear here. All right, now we're just eyeballing this on the peripheral here. We look at the back. When you got a saw cut here, you can't take it for granted that that saw cut is exactly square with the outside. But if you have, like we have that running within 1 here, and if you come out here to the edge and you're maintaining that, you can see that we got just a little bit more difference right there. You could tap this to where you get that straight in line. In fact, actually, when you're working on something like that, that's what you do, is you tap to get your 0 out here, you dial to get your 0 in here, you tap out there, you go back and forth until you're happy with the run out from one end to the other. Okay, for right now, I'm going to let this go. Right here, we're looking at the same thing magnified from what we had here to here. And I'm going to go ahead and I'm going to start drilling and opening up the bore in here. We have to come out 3+ inches in the middle.